So hello, everyone. We're going to be going over the quiz number 4 solutions. I'm going to share my screen. And I have opened up the quiz 4 solutions that are posted on Canvas. So this quiz had 10 question parts, and each of them was worth 10 points for a 100-point quiz. So the first 3 were practice in identifying a parameter of interest from a given scenario. Please pay attention to all the directions I give you. Examples here of how you can respond so that you're sure that you're saying which parameter is being investigated and that you're defining it in words. You can't really get full credit if you just say that you're investigating a population proportion. You have to say what that proportion really is in context of the scenario. So part A, researchers observed 525 female fourth graders and find that 296 of them are over 4 feet tall. So looking at what they are doing by way of their sample and what they seem to be looking for, you can figure out that they're interested in a population proportion because they find that 296 of them are over 4 feet tall. They're counting how many are over 4 feet tall. They're thinking of every person as either over 4 feet tall or not. Yes, no. So you're in proportion territory here. So you're interested in a population proportion. It must be the proportion of all female fourth graders who are more than 4 feet tall. Notice I say all female fourth graders, the population that they're sampling from. If you said that P was the proportion of the 525 fourth graders who are more than 4 feet tall, that's wrong. That would be a sample proportion. You got to distinguish very carefully between a population proportion and a sample proportion. Distinguish between your population and your sample. In the second scenario, you interview 1,000 United States college students and ask each one what percentage of his or her disposable income is expended on takeout food. So each person that you ask this question, they're giving you a number. Like one person might say 20% and another person might say 10% and so on. So even though the numbers they're giving you are percentages, this is not a case where you're investigating a population proportion. You're investigating a population mean. It's the mean percentage of disposable income spent on takeout food for that whole population, for all United States college students. So if like every single person has a number, 20%, 10%, 15%, and you average up all those numbers in the whole population, that's your mu. Part C, in the year 2015, 243 out of 750 randomly sampled towns in the United States with populations less than 50,000 had a majority non-white population. So here, the population is all of the United States towns that are small, all the United States towns whose population is less than 50,000. And out of them, we're wondering what proportion out of them have a majority non-white population. Notice how we're counting up how many had a majority non-white population. Yes, no. So we're interested in a population proportion, and it's the proportion out of all US towns with populations under 50,000 whose population was majority non-white. So the key thing there that people need to review on when they miss stuff is this distinction between population and sample, population proportion and sample proportion. It's foundational for the whole rest of the year. Next question, making an estimate. You wish to estimate the proportion of all college students who accumulate more than 30,000 in student debt by the time they graduate. You do it by taking a random sample of size 1600 and you count up how many in your sample accumulate more than 30,000 in student debt by the time they graduate. what's your point estimate for P? We're just asking for the sample proportion. So that's 750 over 1600. Here I'm using R like a calculator, and I'm showing you here how I did use R like a calculator. So I've got this R code in here. If you just had, 750 over 1600 equals 0.46875, that would be fine, full credit. But I'm just showing you that I'm making it and I'm actually saving it. I'm calling it P hat so I can use it in the future for some computations just down the line. By how much is your estimate liable to differ from P? And I just tell you, you need to compute the standard error for P hat. So the formula is given at the top of the test. It's the square root of P hat times 1 minus P hat over the sample size. So using R like a calculator, I find the standard error. There's a couple of people who they would turn the proportion into a percent, 46.8%, and they would use the percent right here for the P hat in these two places. That gives you a wrong answer. When you're computing the standard error, you really do need to use the fraction, the actual proportion, the things between 0 and 1, not the percent. So I had to take off a little bit for that. Would you be surprised to learn that more than 51% of all college students expect to accumulate more than 30,000 in debt by the time they graduate? Well, this is calling for a z-score. We need to find out, like, how unusual would it be to get the P hat that we got here if the real P was 0.51? And so a z-score is the P hat that we get minus the P of 0.51 over the standard error. Find out how many standard errors our sample proportion is away from this alleged population proportion of 0.51. And it was a lot away. It was 3.3 standard errors below 0.51. Remember, our criterion for unusual is to have a z-score that is bigger than 2 or less than -2. More than 2 standard errors away. Not more than 1 standard error away. A lot of people were saying it was not a lot. Some people were saying it's surprising because 46% was more than 1 standard error away from 51%. It is more than 1 standard error away, but that isn't quite enough to get you to be surprising. Remember, our agreement is 2 standard errors. So I point out that this is more than 3 standard errors away. That's definitely more than 2. So it would be really unusual to get 46% if P was really 0.51. So, like, I might actually doubt whoever this person is that tells us that it's 0.51. 95% confidence interval for P. So the formulas that are the front of the test say you just do sample proportion minus a z-star times your standard error. Here I am, as promised, reminding you that the z-star for 95% confidence is 1.96. And so you get 44% to about 49%. It just said to construct it. It didn't say to interpret it. I'm just going here and interpreting it because I think that's just a good thing to do all the time. But you get full credit if you just construct it. Part E, true or false, if you had sampled 3,200 students and got the same percentage as in this study, the same sample percentage as in this study, your 95% confidence interval would have been wider than the one that you computed in Part D. Well, let's see. If I'd have sampled 3,200 students, that would be a bigger sample. Now, what would happen then to my standard error? Well, the standard error, here's that formula. My P hat is supposedly the same as before, so the stuff in the numerator is the same, but my denominator is now 3,200 instead of 1,600. It's bigger. That makes a smaller fraction, thus a smaller square root, thus a smaller standard error, okay? And a confidence interval is the standard error times the 1.96. So I would have a smaller margin of error. And so my p hat minus my margin of error, and my p hat plus my margin of error makes for a narrower interval. So the answer is false. The bigger the sample size, the less wide the confidence interval will be. True or false? A 90% confidence interval based on the sample that you actually took would be wider than the one that you computed in Part D. Would it be wider? No. The smaller the desired level of confidence, the smaller the Z star is. And so that would make the confidence interval narrower because you'd be using, let me just go up and find it. Yeah, you'd be using a smaller number for the Z star there, making the margin of error smaller. And Part G, based on the confidence interval you computed in Part D, you can be 95% confident that the proportion of students in the sample who expect to accumulate more than 30,000 in debt is somewhere between the lower and upper bounds of that interval. No. You don't make confidence intervals in order to figure out what the proportion of students in the sample is. That's the sample proportion. You already know that. Everybody knows it because they know the sample. That's the 750 over the 1600. Everybody knows the sample proportion is 46%. What they don't know is the population proportion, and the confidence interval is meant to try to contain it. Actually, what you are 100% sure of is that the sample proportion is exactly in the middle of the interval because you take the sample proportion and you add and subtract that margin of error. So that's false. So there were 3 straight falses there. That is the quiz. Actually, people did pretty well. This was the best quiz the class has had so far. There were a good many scores that were above 90. There were several 100s. So that's looking pretty good for a lot of people. Any questions on the quiz? Got some typos there in the solutions. Might go back and fix them someday. Let's see. Next up, I think, is the DA, but I will stop the recording and we'll just have the recording cover the quiz. So let me stop the share and stop the recording.